I'm Anjana Vakil, software engineer and developer educator, and this is TypeScript First Steps. I created this course because when I first started working with TypeScript, I found it really intimidating and overwhelming. So together, we're going to take our first steps into understanding what TypeScript is and how it can help us in our software development workflows. In this course, we're going to learn how to install and configure TypeScript in new and existing code bases, how to start migrating JavaScript code to TypeScript, and we're going to learn all kinds of new syntax and concepts so that we can add more type safety to our code bases. And we'll get acquainted with the TypeScript ecosystem and some of the popular libraries and tools that we can incorporate in our professional workflow. Dive into your next TypeScript project with confidence.
Enough about JavaScript, let's talk about TypeScript. So we said that TypeScript has more syntax than JavaScript. Let's start digging into what that is and what it looks like when we write TypeScript code as opposed to JavaScript code. And there's a whole bunch of words and language terms, like computer science terms, and keywords that we have in TypeScript that we don't have in JavaScript that we're going to be looking at and wrapping our heads around gradually as we go. So what we're going to do now is we're going to start moving in our workflows from JavaScript to actual TypeScript code. So we're going to meet some new syntax, we're going to meet some new ideas and concepts and things that don't exist in JavaScript because, again, TypeScript adds a bunch of stuff. We're going to figure out how to type our code, meaning how do we specify exactly which types we want variables to have, we want functions to take in as arguments or return as return values, and how do we start using types and manipulating them, composing them, putting them together, customizing them for our code that we're trying to write. How we doing? Ready to start writing some TypeScript? I see some thumbs up. Hopefully there's some equivalent of thumbs ups in the chat or a thumbs up emoji. So let's go. We're going to talk about type annotations. And type annotations are how in TypeScript we type all of the values. Type all the things. I guess this meme is super old by now, but I'm also super old, so all of my memes will be old. Get used to it. So when we talk about TypeScript, we're usually having in mind JavaScript with specified types. And that is exactly what we're going to start articulating by using what TypeScript refers to as type annotations. So unlike in JavaScript, where, as we said, we have dynamic types, so a variable can take on different types throughout its lifetime. It can change throughout our program. In TypeScript, we have a way of making sure that a variable always has a certain type of value. So for example, if I am declaring a variable n in JavaScript, as long as it's a let, would not care if I change that from a number to a string or something completely different. But we want the language to care. So in TypeScript, we can add a type annotation to a variable declaration with a colon and then the name of a type. Now in this case, we're using a primitive type. We'll talk about this later, but this is the type that we've probably also seen in JavaScript, number. And it, perhaps not surprisingly, is going to tell TypeScript, hey, this variable n, it must always be a number. And that means if I change, it's still a let, it's still a flexible variable. If I change the value, but it's a number, that's okay. That's not a problem as far as TypeScript is concerned. But unlike JavaScript, TypeScript does care if we try to make it a string or an object or an empty array or whatever, because we told it that it was supposed to be a number. So I'm just going to copy this to the playground. And so here we can see, just as just a quick and easy way to see that, unlike JavaScript, on line 3, TypeScript gives us an error. It says this value, which is a string, is not assignable to a variable that's supposed to always be a number. And how did it know that it's supposed to always be a number? From this colon number right here. And likewise, we could do the same thing with different types, like a string variable. In this case, I'm also passing in, it's another primitive type in JavaScript, which also works in TypeScript, so a string. And now, s is going to always and forever have to be a string value, and we will get a similar error if we try to make it null or empty object or whatever. So this is how we annotate or type variables in TypeScript. Colon, type name. Well, colon space type name. Now, let's talk about this pipe that I keep hand waving away. What is that? And this pipe represents a way to define what TypeScript refers to as union types. The idea here is that it's sort of a way of telling TypeScript that the type that this value can be might be any of these types. So if I have a variable number or string, I can say, hey, I'm not sure exactly what this is going to be, but I know it's not going to be an object. I know it's not going to be undefined or null or blah, blah. It's going to either be a number or a string. And that is what this pipe operator does when we're declaring the type. And what this tells TypeScript is essentially, if we think of the number type as like the set of all numbers, and we think of the string type as like the set of all strings, as opposed to a literal type, which is just that one particular string, for example, by putting that pipe there, what we're doing is we're creating the union of these two sets. And so now we have a type that can be any of the numbers or any of the strings. So it's a way of kind of combining two types together to make one, what we'd call wider type. So numbers over here, strings over here, number or string, all of it. And similarly, we saw how the optional property gave us, the question mark gave us a number or string or undefined. We could do the same with, like, we could make a nullish number, where this could be null. Whether or not that's a good idea is a different question. But if it has a value that's not null, that value better be a number. And so that's where, if we try to assign a string or an object or anything else, we will make TypeScript mad. Because it says, hey, null is not assignable to the type you gave me, and the type you gave me was the union of the type string and number. So whatever value you give to this variable, it has to fit in that union. And similarly with our number or nullish number. We can make it null, we can make it a number, but we can't make it anything else. Can we make it an array? Ooh. Oh my God, can I make it an array? No, we cannot. And here it's saying, okay, you gave me a value of type string array. We're going to talk a little bit later about how did TypeScript know that this is a string array value? We're going to talk about that later. It's called inference. But either way, it's like that's not one of the types that was in the union. But what if I wanted it to be? What if I wanted this to be able, oh, sorry, let's make this something a little bit more sensible. What if it's like, it could be a number or it could be a bunch of numbers? I can even add more pipe operators to do something like number array. And now what this is saying is, maybe it's a little easier to read if I move the null to the end. Okay, so this is saying, hey, okay, maybe this number or numbers or null is maybe a better terrible variable name for it. Ooh. Wow. What I'm saying is, okay, maybe this is something that like later I'm going to pass into like sum all of the numbers, and I have to handle the logic of maybe it's an array of numbers, maybe it's just one number. I can define a type like that using the pipe operator to add, in addition to a single number, we could have an array of numbers, or we might not have anything at all. We might have null. And that then means that it's fine if I want to assign it to an array of numbers. However, an array of strings? No. Not going to work. So now we've got similar problems. Now, this time, if I start just typing an annotation here, I haven't imported any of my types yet. But if I do a :id here, luckily there is no name collision with like a built-in JavaScript thing. And so TypeScript is able to be like, hey, oh, are you talking about that ID type that you just put in your types module? And so if I now press tab, not only does it like the type here, but it actually added the entire import type statement for me. So this is, again, we're now leveraging all kinds of tooling under the hood here. We've got VS Code and TypeScript working hand in hand to look at all my code and figure out where the types are and guesstimate what I'm trying to do as I'm typing. Yeah, question?
Yeah, I was just gonna see, so like, you're bringing in the type of ID, but like what would be the benefit of doing that over bringing in the type of user and then doing like a pick user ID for the ID, so then it knows it's a user ID rather than just an ID?
That is a really great question. So what we had done here is we took one approach to getting an ID type that we can work with, but there's a whole bunch more. And so, for example, we saw pick. That is one way to get kind of a subtype out. However, there is another way that we can get an individual like property from within an interface like this and get the type of that. So one way that we could have done this, like for our events, we could say, okay, we have an ID, and that's just like any kind of ID, and maybe it shows up in events, maybe it shows up in RSVPs, who knows? However, another thing that we could do is say, hey, we've already got this user thing, and the user thing has this ID, and that is what we want in our users file. We don't want just any ID or like maybe a more general type, a wider type. We want the user ID. And there is a way that we can do that in TypeScript. So first of all, I need to export this. And then now I can import, let's say instead of ID, I import type user. Now, of course, TypeScript does not know what I'm talking about. And here did it autocomplete? Oh, it's just complaining that I haven't actually used this yet. Now, if I were to say that this is a user, I would be lying. But TypeScript doesn't know. I'm telling it what the type is. But what I really want to do is to say this is the type of the ID property on the user type. And there is a syntax we can use in TypeScript that's a little bit similar to, like if we had a user object that was a user, and we wanted to say like ID1, whatever, and then of course it's going to complain because it's missing all of the other stuff. Then later I could do u.id, blah, blah, blah. That works with JavaScript objects, the dot notation. However, in TypeScript, we can do I'm just going to give it an alias so that we see it on this one line. Let's say I make a type that's user ID. We can drill into an interface in a similar way using different syntax. So we can use angle brackets, much like if we were trying to get a property out of an object, we can also use this syntax, where we then, inside the angle brackets, and I opened a string, and VS Code and TypeScript together collaborated to give me all of the keys that exist on this type in a similar way that, like, we can access objects by index in an array, or, can access values by index in an array or by property name in an object. We can access types on an object type with this angle brackets and then the name, the key that I want for that property. This is what's called indexed access types, if you're looking for jargon. And essentially what this does is it goes to user and it finds the ID and it sees that it's a number, and that is the type. And so now I could use this type alias here, or I could forget about the type alias and just inline this into where I actually need it if I'm not going to be reusing this user ID all over the place.